Hi, Calculus kids. This is Dr. Callahan with week 9, Tuesday. Here are your 3 questions. All right, let's go ahead and take a look at this question right here. So this is a good question to find for the AP test to ask you to find the equation of the tangent line with the function y equals 8 over x squared plus 1, and then they want you to go ahead and find the equation at 1, 4. So first thing I'm gonna do is I'm gonna rewrite this. I can't do the derivative in a fraction unless I want to use the quotient rule, and if I can avoid that, I will do that as much as possible. So I'm gonna move the x squared plus 1 up to the -1 power. So then I'm just gonna go ahead and use the power rule followed by the chain rule. So y prime equals, bring that -1 down, -8 x squared plus 1 to the -2nd power times the chain of what's inside the parentheses, the derivative of x squared plus 2, or excuse me, x squared plus 1 is just simply 2x. I want to go ahead and simplify this a little bit more to make it look a little bit better. So I have a -8 times 2, so -16x. Bring down that -2 to the denominator, x squared plus 1 squared. And that right here is going to be your slope as well. Now you can find your slope because you are given the x value, which is a -1. So -16 times 1 is a -16. 1 squared is 1. 1 plus 1 is a 2. 2 squared is a 4. So your slope is a -4. So I want to find the equation for this, and you could either use slope-intercept form or point slope form. I'm just going to go ahead and use point slope form because I feel like I use slope-intercept form quite a bit. And so that is y minus y sub 1 equals m times x minus x sub 1. And given the fact that you have x here and y here, I have y minus 1 equals -4x minus x sub 1, which is a 4. Distribute -4, you have y minus 1 equals a -4x plus 16. And then add the 1 on both sides, -4x plus 17 is your equation to the line at this point. All right, so yesterday when I saw you guys, we did a calculus puzzle that I introduced you guys to the derivatives of L and U. And so your answer here should be, how can two lumberjacks chop trees in perfect synchronization with natural logarithms? I thought that was pretty cute, pretty nerdy, but pretty cute and clever. In addition to that, we went ahead and went over several other questions in class involving this. There was one in particular that I didn't go over, but I thought it was, kind of an interesting one. And somebody did send me an email stating that they were a little bit confused about having an ln instead of an ln(x). And so let's go over number 19 for this question. So I introduced you guys using U because sometimes having like a chain inside of a chain inside of a chain is really, really complicated, and that can get really difficult to do. And so that's why we use U substitution to make things a little bit less confusing, a little bit more organized. So I'm just saying let U be ln x. Then I know U prime is 1 over x. So then when I go ahead and I substitute this in, I know I have ln, I'm replacing the whole ln x with U, ln U. So then y prime is 1 over U times U prime. So that's it. You are all done with your derivative. But your next step is you have to go ahead and replace everything back. So then I have y prime is equal to 1 over u. U is ln x times u prime. U prime is 1 over x. So your answer actually is just going to be 1 over x ln x as your derivative. And that is O right here. And I believe it was number 19, so O will be number 19. Okay, so then today, or actually before I do that, another thing I had you guys do was this part right here, which is a review question of Unit 1, because you cannot forget things from Unit 1. Your AP exam, which is coming up in May, is actually cumulative. So everything that you learn from week 1, Monday of semester 1 is fair game on there. And I can tell you right now, they'll have these questions on there. And so let's go over some of these answers. So take a look at my steps right here for the first part of the review. And then take a look at the second part. Okay, so let's proceed forward with today's stuff. So here's the breakdown we're going to talk about today. We're going to talk about chain rules with transcendental functions. Transcendental includes those are trig, ELN. So we've done trig, ELN, and now we're going to go on to logs. We're also going to do something called PVA, which is position, velocity, and acceleration. I actually introduced you guys briefly over that last time. And so more practice on motion particles, f of x, PVA. All right, guys. So your notes today looks like this for week 9, Tuesday. This is your first page. And here's your second page, which is we're going to be starting on with the PVA. Okay, and so let's go ahead and get started with that first. Go ahead and read the questions to yourself. Okay, so you have a particle that's moving in a horizontal line, and this right here is the position function, S of t. And it's measured in meters per second. So it's asking to find the instantaneous velocity at this time, and you guys know that, remember, S of t is the position function. S prime of t, the first derivative, is going to give you velocity. Okay, so let's go ahead and do that. So if S of t equals t cubed minus 12t squared plus 36t, then S prime of t is going to give you velocity, is going to be 3t squared minus 24t plus 36. And that's just a simple power rule. And it asks you to find the instantaneous velocity at t equals 3 seconds. So I'm going to do v of 3, which is going to be 3 times 3 squared minus 24 times 3 plus 36. Well, 3 squared is 9. 9 times 3 is a 27. 4 times 3 is a 12. 6, 72 plus 36, which will give you a negative 9 meters per second. And that's your answer for A. For B, it asks you to find the average velocity in intervals 1 and 2. So just keep in mind that your slope is going to be y sub 2 minus y1 over x sub 2 minus x1. And that is in relations to the change in position divided by the change in time. Y is related to position, x is related into times, which makes sense because if you look at S of t a lot of time is like f of x, okay, which is f is the same thing as saying y. So Your S is your Y, which is change in position. And remember, your position is always like meters per second. So meters come first. And then the bottom, the denominator is represented by X, which is T. T is time. So it's always seconds. So time in seconds. And then change in positions. Position meaning distance using meters. So let's take a look at this. You have the intervals 1 and 2, and because of the keyword is interval, you know what x sub 1 is 1, x sub 2 is 2. So grab your calculators. We're going to have to find some values of y's because in order to find the slope, you will need to have the y value as well. Be very mindful that this is not x1, y1, it's intervals, so it is just x1, x2. So then let's plug it in. What is S1? And when you do S1, remember it's going to be 1 cubed minus 12 times 1 squared plus 36 times 1. And then S2, same thing. And you should have a 25 in the first one. And then a 32 for the second one. Now that we have the y's and the x's, I can now plug this into my slope formula. So my slope is going to be s of 2 minus s of 1, which is y2 minus y1, divided by 2 minus 1. So I'm going to relay those numbers back. That's 32 minus 25 over 2 minus 1. And so my slope here, or the average velocity, is going to be 7 meters per second. All right, let's go on to C. For C, it says, when is a particle at rest? At rest would mean that the velocity is going to be at 0. When is going to be moving to the right? And then when is it moving to the left? Justify your answer. Okay, so if you're looking at this for time, this is when, meaning that we're going to have to find time. That means I will have to go ahead and modify the position function. So looking at this part right here, I know that my velocity is going to be 3t squared minus 24t plus 36, which is equal to 0. So then I can factor out the 3 to solve for t, because that's my goal. So then I have t squared minus 6t plus 12 equals 0. Let's go ahead and factor that. So you're going to ask yourself, what times what gives me a 12, but when I add it together, it gives me a negative 6. And that is going to be a t minus a 6 and a t minus a 2. Oh, wait a second. I'm sorry. Hold on a second. Hold on. Oh, you know what? That's an 8. That's why. I was like, this is not correct. There we go. Negative 8. Because 32 divided by 3 is negative 8 equals 0. So then from here, my times is going to be 6 and my time is going to be 2. So with these side, I'm going to go ahead and draw my table. 2 and then 6. And so as I'm looking at this, it says when is a particle at rest? At rest means that it's not moving, so I'm put a 0 right there. And then we're going to go ahead and pick some points that's in between 0 to 2 and some points between 2 to 6. And remember, this is velocity. So what's a good number to pick between 0 and 2? I will say 1. So I'm going to put in v of 1. A good number to pick between 2 and 6, I would say, I mean, I don't need that big of a number. Let's just do 4. So V of 4. And then to the right side of 6, I could do a 7. Given the fact that your velocity is right here, this is your equation for your velocity. Plug in 1 into velocity, plug in 4, and plug in 7. And ask yourself, does it give you a positive or a negative number? V of 1 is going to give you a positive 15. V of 4, once you plug it in, is going to give you a negative 12. V of 7 is going to give you a positive 15. So that's telling me that the slope is positive between 0 and 2. And then between 2 and 6, it is a negative. And after 6 is going to be a positive. And so answering the question, it says, when do I know if it's at rest, when it's moving to the right, when it's moving to the left? I will go ahead and say that this particle is moving to the right between 0 to 2. In addition, between 6 and to positive infinity. Why? Because V of t is greater than 0, and also it's positive. Now, on the opposite side, I can say that this particle is moving to the left in between to the 6, 2 to 6, because the V of t is less than 0. And those will be my responses. Okay, I'm going to have you guys go ahead and take a look at the next part, which is D. And take a look at D, E, and F. So then for D, it says, when is a particle changing directions? Well, I knew that it changed directions between 2 to 6 seconds because it went from a positive to a negative and from a negative to a positive. So you can say that this particle changed directions at t equals 2 and then at t equals 6 seconds. All right, let's go ahead and take a look at E. All right, so finding the displacement of the particle means that you will have to go ahead and subtract. And it says first 8 seconds, so you will have to subtract when the particle is at 8 seconds minus the particle at 0 seconds. Because it's from first 8 seconds, so starting point at 0 seconds to end at 8 seconds. So given the fact you're talking about displacement, you're going to be looking at the position function, which is going to be S of t. That's the one we're going to be using. So you want to go ahead and find S of 0, because that's when you start. And you also need to find S of 8, because that's when you end. Well, let's plug this in. S of 0, because you're using this equation right here, is 0 cubed minus 12 times 0 squared plus 36 times 0. Well, it has 0 on all of the terms, so it's just going to be 0. Similarly, make sure you put 8 cubed minus 12 times 8 squared plus 36 times 8. You could plug that in. An easier option of doing this is the second calc option in your calculator for the TI-84s. What you can do is you can go ahead and graph this and just write down t cubed minus 12t squared plus 36t in the graphing portion of your graphing calculator. And then what you're going to do is you're going to do a second. So push the second button, then do a calc button, and you're going to go down to the X option, X equal option. And then you're just going to type in X equals 0, X equals 8, and click enter. And it should tell you exactly what is your Y value when X equals 0 and when X equals 8. And this is actually going to give you something of 32. So then what you're going to do, you're going to subtract the 2 because the displacement is the distance between the 2 right here. So you subtract it, and it's just going to give you a 32 meters. And that is your answer. That is a displacement of the particle after the first 8 seconds. Okay, for F. So it's asking you for the total distance traveled by the particle during the first 8 seconds. Because the particle is moving back and forth from left to right, remember in the beginning, it is going from 0 to 2 seconds, so it's going over to the right. So it's going to the right. But then between 2 to 6 seconds, it's now going over to the left. And then after that, from 6 on forward, it's now going to go back to the right again. So the way I kind of remember this is, like, if I were to go ahead and drive my car from my home to my work, and then from my work back to my home, obviously, it doesn't mean that I didn't drive anything, because if it took me 10 miles to go from my work to home, that's 10 miles going in the right direction. But then I have to drive all the way back 10 miles. So I will have to add these miles together. So what is my total travel time? It'll be 20 miles because I'm going from home to work, that's 10 miles, work back home, another 10 miles. So 20 miles altogether. I will have to go ahead and add them. So if I were to find the total distance traveled by the particle during the first 8 seconds, I will have to do S of 0, S of 2, S of 6, S of 8. So grab your calculator. I would recommend doing the second calc option and just type in X equals 0, X equals 2, X equals 6, oops, X equals 8. Okay, so then S of 0, you have a 0 there, a 32 for 2. At S of 6, it's 0. S of 8, it is 32. So I will have to find the spaces in between them. 32 to 0 is going to be 32 meters. From 32 back to 0, I mean, it's kind of like I went back home, so 32 meters. From 0 to 32, 32 meters. So then if I just go ahead and add them all together, my total distance traveled is 96 meters for the entire trip. Okay, so looking at G, this is find the acceleration of the particle time at t equals 3 seconds. So you know that the velocity that we had is 3t squared minus 24t plus 36. Well, remember, acceleration is going to be the first derivative of velocity. And remember, your velocity was the first derivative of your position function. So acceleration will be the second derivative of the position function, which is 6t minus 24. And again, if it's acceleration, it'll be meters per second squared. And since we're given to find that a of 3 seconds, so a of 3 is 6 times 3 minus 24, which is going to give you a negative 6 meters per second squared. All right, so for H, it says Is a particle speeding or slowing down at t equals 1 second? So let's do this. V of 1 at 1 second, plug this into this equation right here for V of 1 is going to give you a positive 15 meters per second. When you do A of 1, which means you're plugging into this acceleration equation, it is going to give you a negative 18 meters per second squared. And since given the fact that these two, the velocity and acceleration, has opposite signs, you know that the particle is slowing down at t equals 1 because the velocity and acceleration have opposite signs. So is the particle velocity increasing or decreasing at t equals 2? Well, let's take a look. A of 2, plug that into this equation here. I know you're like, I have 3 equations. I got to keep track of which one I'm using, and you're absolutely right, you do. So this is your acceleration. So acceleration at A of 2, is that going to give you a positive or a negative answer? And if you plug it in, it is going to give you a 6 times 2 minus 24, which is going to give you a negative 12 meters per second squared. And that is a negative. And so since A of 2 is less than 0, which is negative, the velocity is decreasing at t equals 2. And that was how you will respond to that. If you need a little bit more assistance, I do have the link right here that you can go ahead and find more steps to it to follow. But I think that was pretty thorough in terms of one of those, questions on the free response where you have like A, B, C, D. This one actually broke it down quite further. It has A, B, C, D all the way down to I. Now, if you feel like you need some additional assistance, I would highly recommend that you go ahead and take a look at this part right here. I have 2 different problems that is very similar. And if you need the steps, the answers on this link right here. Capital T, capital J. All right, you guys, I hope you guys have a good day. And as always, stay safe and healthy. Take care.